The second dynamic protocol is link state protocol. That is OSPF. We'll see the example of OSPF. And what is OSPF? Open short path first. So what is open short path first? OSPF. It uses digit cross algorithm. Okay. It uses digit cross algorithm. What is this algorithm? You have to study on your own only. That is not needed now. And what is the difference between RIP and OSPF? RIP uses metric as hop count and it will work as a routing by rumor. It will work like if anyone is telling that is the thing, it will take. Okay. But OSPF will not take like that. And there in RIP, what is the metric? Hop count. Here the metric is 110 cost. How you can calculate the cost? 10 divided by bandwidth in BPS. Okay. Bytes per second. Third one, you can write it as 10 power 3 divided by bandwidth in megabits per second. Megabits per second, not bytes, bits per second.
Okay.
Okay.
Then it will be small b now.
Yeah. Bits per seconds. Then anything you know about this? It has area concepts. Okay. Then it maintains 3 tables. What are the 3 tables? Neighbor table, neighbor table, then topology table, then routing table. It maintains 3 tables. Okay. This table will tell you who are the neighbors. This table will tell you what? The entire topology. What is there, that side, this side, everything. This routing table will tell what is the best path to do. Okay. These 3 tables will be maintained. Okay. Then we'll see how area controls works. If you have a router here, suppose if it is in area 0, area 0 is also always called as backbone router. It's a backbone for all the areas. Area 0 is a backbone. So I can connect with the area 0 with all other areas. Suppose this is area 1, this is area 2, this is area 3. You have to connect with area 0 only. If you have area 5 here, suppose here area 5, this is of area 4, this is of 3, this is of 2. Okay, you cannot connect area 5 with area 4. Why? Because I told you backbone I want to connect. Only with area 0 only I have to connect all other areas. I cannot connect the other area like 5 area with 4. Or 5 to suppose there will be a problem, I have to connect area 4 with area 5. Still I can make it through the virtual links. I have to make a virtual link with area 0. Okay. It, without virtual link I cannot make a connection with this 4 and 5. Okay, all the areas should have to be connected with area 0 only. If it is not possible, you want to make a virtual link with the area 0 when the condition is there will be only one router in between or one area in between. Not router, one area if it is in between. If there is two row areas in between. Okay, there is one more area here. Like this is of 2. This area number is 2.
2 is already there. 1.
Okay, 1. You cannot connect like this. You cannot connect 4 with 1 and 1 with 4. You can make a virtual link 1 with 0. You cannot make virtual link 5 with 0. It is not possible.
Why would not with 5?
Hmm? I told you there should be only one area in between. You understand or not?
Why 1 area in between means?
That's what I was telling you now. Before that, there was no area 1.
Hmm.
Still, if I don't have that capacity to connect with the area 0 only, I can connect with area 4. But I have to make a virtual link between area 0 and area 5.
Hmm.
When there is a condition of area only one area in between area 0.
Oh, only 1 area. If
One
2
area,
areas
if
means
two
it can
areas is
connect.
there, I cannot connect with 2 areas. I cannot make a virtual link between 5 and 0. So I cannot make virtual link between 5 and 0. That is not possible.
Hmm.
Only one area, this area can connect with area 0 through virtual link. Okay, but this 5 will not be cannot be connected with area 0. So in that condition, what we want to do, that is CCNA concept actually. This area, this virtual concept. Okay, this understood now. All the areas with that will be connected to area 0. If that is not possible, we can still make a virtual link.
You explain that
Then,
also. Finish it up.
okay, then this is area. Now we'll see about DR and BDR elections. Okay, suppose I have 4 routers, which is connected with a switch. The symbols are wrong. Still, it is easy to make it itself. I have 4 routers, which is connected with a switch. Okay, like this I have. Okay, now this router will introduce about this to whom? To this, to this, to this. Then this router will introduce about itself to this, to this, to this. This router will introduce about to itself to this, and to this. So what happens now? There is a broadcast storm. There will be storm happens. If suppose 4 routers, okay. When it becomes 100, it will create a broadcast storm so that it will become all down. Switch will become down in between. In this switch, suppose switch will become down. So in order to stop all these things, we are coming to a concept called DR and PDR. Okay. How DR elections happens? DR election happens by highest loopback address. If I have the highest loopback address, I will become a DR. Suppose I have here 10.10.10.10. I have here 1.1.1.1. Here 2.2.2.2. Here 3.3.3.3. So who is the highest loopback address? This is the highest loopback address. This will become DR. If suppose the router doesn't have any router ID, sorry, not router ID, the highest loopback address. If there is no loopback address, it will take it as highest interface address. Okay. If that is, you can give manually also
Interface address of the switch or the router?
the interface address of this one, not that switch, this one,
Router, na?
router.
Okay.
So then I can give manually also the router ID. Again, hardcore router ID, if I give, that also will be taken. Whose router ID is big, that will become a DR.
Yeah. Just
Okay.
like a selection of
Yeah, yeah.
root bridge.
Highest loopback addresses become a router ID of me, then it will become a DR. If suppose I have highest interface ID, that will become a router ID for me, that will become a DR. I can give the router ID by myself by giving the command router ID. These things I can do. So
If not, then MAC address.
no MAC address allowed. There's no MAC address concept.
Because
Okay.
so router ID comes up if you are not configuring.
If
Then
you're not country anyway, so then no dear behavior elections.
okay.
Okay. Next thing is like DR to DR other. That this is DR.
Mm.
This suppose this is a DR. This is DR. BDR. This is DR other. This is also DR other. This is not Rother.
I didn't understand what is DR other and BDR.
DR is a head, is a subhead. These are DR others. And normal people.
Raw BDR got selected.
The next one, the router ID, suppose this is 10. This is highest loop, next highest loop, highest router ID. This will
Okay.
become a BDR.
Okay.
If two are elected, these remaining all become DR other.
Okay.
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 Now, the thing is, DR to DR, BDR, all the information will be shared. They will share all the information with each other. If once DR gone down, this will become DR.
Mm.
This will become DR now. Okay. Once DR gone down, BDR becomes DR. Who is the next highest route ID become BDR.
Mm.
This will become BDR now. Okay, suppose for example, I'll take here. This is 4.4.4.4. This is 3.3.3.3. This is 4.4.4.2. This is 1.1.1. So who will become DR now? 4.4.4. This will become BDR.
Mm.
This to become DR other. When 4 gone down, what happens?
3
This
will
gone down,
become
3
DR,
become DR,
2 will
and
become
2 will
BDR.
become BDR. If this also gone down, this will become DR,
That one will become BDR.
this will become BDR.
Yeah.
Okay,
Yeah.
this is the concept of DR and BDR connection.
Mm.
And what happens? DR and BDR will share each other, so that if it goes down, this will act as a backup. That's just a backup.
Mm.
But DR other to DR other only share information of the neighborship.
Mm.
Only it will share about the neighborships.
Mm.
But DR other will share all the information of the DR.
Mm.
Got it?
Mm.
This will share only the small information. So what is the small information? I'll tell you. This will share some small information. That is two-way handshake.
Mm.
Up to here, the full will be
Two-way
done.
handshake.
Yeah, I'll tell you. Two-way handshake, and here full will be done. Okay.
Means all the DR, BDR, and DR other, everyone will give complete information to the DR.
Yeah. Okay. DR will tell if anyone comes, he will tell the information about him. So DR to DR other, DR to DR other. To what is the multicast address it is using? 0.5 is the multicast address. DR other to DR. What is the multicast address? 225 dot 224 dot 0.0.6 is the multicast address will be used. DR to DR is 5. DR to DR is 6. Got to know this concept. What is DR and BDR? How election happens? Why DR and BDR?
Okay, what's the main function of DR and BDR?
See, that's what I don't want to send the broadcast storm. Everyone is telling to everyone that I am this, I am that, I am.
Okay.
So I don't want to tell the broadcast so that this head will share any information with this one.
Okay.
Okay. So this will act as a head. This will share the information. Got it? Okay. Now what are the different states I have? I have 7 states in OSPF. There is not CCNP, in CCNA only. There are 7 states in OSPF. What is the first state? First state is called as down state. What is the use of down state? In down state, it will send the hello packets with everyone. Okay, who is the neighbor? I will send the hello package.
To
Hello,
everyone.
yeah, that is, it will send the connected persons who run OSPF. It will send the hello package. Okay, to the neighbor welcome. Hi, I am this. I am you. I am. My address is this. Your address is what? Like that, it will share everything. Before that, before sharing, it will send a hello. Hi, hello. It's of 10 seconds for broadcast multi-access networks. Broadcast multi-access means who can connected the fast Ethernet cables. There are called broadcast multi-access. Who are connected serial cables, there are point to point. Who are connected frame relay, they are called NBMA, non-broadcast multi-access. Got it?
You write it.
Broadcast means you have fast Ethernet cable, that is called broadcast multi-access networks. There is a 30 seconds for NBMA networks. What is NBMA? That is called as frame relay. Okay. What is point to point? Serial cables are point to point. These numbers we can change. There's 10 seconds, there's hello packets you can change. What is dead timer? Dead timer is 4 times of hello. It should be always 4 times. If you are changing hello 20, you should make it dead timer as 2 into 80. Okay, always. It should be always 4 times of hello. Okay, this is hello. First, while sending the hello, it will send about the area ID, subnet mask, okay, authentication passwords, stack flags. This you will study in CCNP. Stack flags, no? And MTU size information. Okay, then area information, then router ID information, everything. Router ID. These things and all will be shared with the hello packets to the next neighbor. This is hi hello. My area is this thing. My subnet mask is this thing. My password is this thing. My stack flags is this. MTU is this. Router is this. What is the next state? Next state is called init state. State 2 is init.
It is state 2 only.
Yeah, this is of state 1. I made it in capital. This is state 1. This is state 1. This is a state 2. What is state 2 will be? Once these packets are matched, area ID is matched, authentication pass is matched, stack flags are matched, it will check, it will match with all the parameters. If all the parameters are matched, if all are matched, then it will send it to two-way handshake. Then it will go to two-way handshake, two-way state. Okay. What is two-way state? What is two-way means? Once if the parameters are matched, then it will come to two-way. In two-way, it will become neighbors. If it is not already neighbors, or else it will become neighbors. If it is a neighbor already, it will just refresh the routing table. It will just refresh the routing table. What is two-way? See, first I will send you hello. With hello, I will send you with parameters. Next way is init. Init, I will see what are the parameters matched. Then we both will go to two-way state. If we are already friends, then I will just refresh that we are friends. If we are new friends, I will make a neighborship. Then what is the fourth state? What is the fourth state? Fourth state is extract. Okay. In extract, what will happen? It will elect DR and BDR. DR and BDR election is mainly based on priority, okay, plus route ID. This priority can be changed. Plus route ID, who wants become DR, who doesn't want become BDR. Next is highest is become BDR, all others are DR others. Then fifth state is exchange. What exchange? Here they will use DBD packets. Here it will use DBD packets. What is DBD packets? Data descriptor packets. Database descriptors. Here we will send all its database to you and we will send the all database to you. Then what is sixth state? Loading. You have ever seen loading is done like that? When you run OSPF, it will come as loading is done. I will show you now. So loading means it will ask, okay, link state, request, it will ask, this is my thing, please I am requesting you send me your details. It will reply back with it will reply back with it will reply back with link state update. Okay, that is called loading. Whatever information it has, suppose it has this side it has 1.1.1.1, this side has 2.2.2. It will ask, I am 1.1.1, what is yours? It will send an update that I am 2.2.2.2. Again, this will ask the request, this will send an update. So request and update process called loading. If once loading is done, full is the last state. What is full? It will exchange all the routing information with each other. Will exchange all the info with each other. So these are all the states. Okay. So DR to DR other only it will go up to 2 state. DR other to DR, DR other to DR, sorry. DR other to DR. When two normal people are there, DR other, two normal DR other, they will go up to 2 states. It will never go to this DRB election, DBD packet sending, link state request update. There is nothing will happen like that. But DR other will go to the DR all the state. Because DR should not know everything. And BR also should know everything. But DR other with the DR other only up to 2 state. Normal people will go up to 2 state. That is normal people DR other. With head all the states I will go. Okay, na? Understood, no? These are all the different states in OSPF. This is the theory.
Save.
That's in video. No? Okay, first what we'll see R1. How to configure the router OSPF. Router OSPF, you want to give the process ID. It is locally significant for the router. If you are giving router OSPF 1 here you are giving router OSPF 2, nothing will happen. This is not an autonomous system number. You can give any process under OSPF, but you have to process under number 1, like that you are telling. Okay, then network, when you are giving it in RIP, it will take it as a or class full. Here also I can give 10.1.123.0, but not like RIP. I want to exactly match with the wildcard mask. How wildcard mask is just ultra of subnet mask. I am matching up 10.1.123. Correct? 0.0.0 means I am matching up to 1 to 3. Okay, this is the thing I am matching. Then I want to tell about which area I am in. I am in area 1 here. Okay. Then I want to tell about the network, the loopback address. Correct. 100.0.0. I have 4 loopback address 0, 1, 2, 3, and I will do that. I have the loopback address 1.1.0.1, 100.1.1, 100.2.1, 100.3.1. Like I have 4 loopback addresses. Okay, I have to introduce about this also.
0.0.
Dot 3.255. Instead of 252, I can write as 3 in wildcard marks. Which area? Area 1. Okay.
Why?
Hmm? 0, 1, 2, 3, 4. Wildcard mask always starts with 0. 0, 1, 2, 3. That means 4 address I have. Okay. Done. That's all about the OSPF. Now we'll run in router 2. Router OSPF 1. Network is 10.1.123.0, 0.0.0.255, area 1. Network. See what it happened. Loading to full done. Loading done. What is loading stage? Sixth stage. We have seen loading done.
Fully
Full.
disaster.
Yeah. Understood now. Then network I am introducing about 2 network. I can exactly match also. Area. So 1. That's all. Then we will go to router 3. Router OSPF 1. Network 10.1.123.0, 0.0.0.255, area 1, network 3.0.0.3, 0.0.0, area 1. Okay, then we will go to 4. I want to introduce about this network also in R4 as area 0. 10.1.45.0, 0.0.0.255, area 0. That's all. Go to R5. 45.0, 0.255, area 0, 5, 6, enter 5.5.5.5, 0. OSPF, router OSPF1, network is 10.1.56.0, 0.0.255, area 0, network 6.6.0.6, 0.0.0.0, okay. Now I can able to see in R1 no? All the routes. So IP route, OSPF is the command. So only the OSPF routes. I can able to see 2, 3, 4, 5 and 6. All the routing table I have got now. Correct. Now, who will become DR in this? This is a multi-access, right? This is a BMA network, broadcast multi-access network. So in this network, who will become a DR and BDR?
In this network, will
Yeah.
become DR and will become
Become
DR.
DDR.
Okay, this one is 1.1.1.3
These all have 2.2.2. This is a 3.3.3.
and 4 has 4.4.4.
Yeah, yeah. The first day only
4
told
will
me.
become DR
And
and R3 will become BDR.
sure,
Sure.
100%.
100%.
I will tell no. Let's see. Show IP interface F0 interface F0 slash 0. Show interface F0 slash 0. So what is my MTU size? These are all the things first I will tell you. Who will become DR? I will show you. First I will match it up with all the MTU size. All this stuff I will match it. Then only I will become neighbor. Space interface F0 slash 0. So I am, who is DR now? 1.1.4.1 is the DR. Network type is broadcast. Okay. Network type is broadcast because I am using fast Ethernet cable, so it is network type is broadcast. And what is the route ID? Highest loopback address. What is the highest loopback address of R1? 1.1.
3.1.
I have 4.1 also. 4.1 becomes route ID. Okay, one more. Route 1, route ID is 1.1.4.1. No, correct.
Mm.
So I became a DR. Who is became a BDR? 2.2.2. How come? And hello is 10. This is a broadcast I told. Broadcast is 10. Wait timer is 4 times of hello and wait time is 40 seconds. So how this R1 becomes DR and R2 becomes BDR, R3 and R4 becomes DR other. How come? I don't know. See, when your OSPF is started, within 30 seconds of time, DR and BDR election will happen. Okay. So when I start with R1 only, it will start the DR election. Once the DR election is happen, it will never happen again.
Okay.
Got it? When I started with R1, the election is started, so it became DR, this became BDR. Once the election is over, no re-election will happen. Until this is down, until R1 is down, no re-election will happen. Okay, so how can I make now? I'll go to all the interfaces F0 slash 0. I'll shut down the OSPF process. I'll start equally at the same time. Okay, I'll go to interface F0 slash 0. I'll shut down it. I'll go to all the interfaces. Interface F0 slash 0. Shut. I'll go to R3. Interface F0 slash 0. Shut. I'll go to R4. Interface F0 slash 0. Shut. I have shut down all the interfaces. I'll start all the interfaces at the same time. Now, who will, if I start all the interfaces at the same time, who will become DR?
4.4.4.4.
Who will become BDR?
DR.
BDR. DR becomes 4.4.4.4. Who will become BDR?
R3.
R3 become BDR. This R1, R2 becomes
DR other.
DR other. Let's see. We'll start up together. No shit. No shit. No shit. No shit. We started the routing OSPF protocol. Show IP OSPF together. Interface of 0 slash 0. Now what it is coming, there is no designated router on this network. Election is happening. DNB election is happening. Election is still happening. Now who became DR? 4.4.4.4. Still election is happening. Who become BDR?
3.3.3.
Who become BDR now? 3.3.3.3. Who become DR? 4.4.4.4. So why? Because initially this was when I was running OSPF, that time only election will start. Okay, that's why this become DR and this become BDR. Now I started totally equally together. Now it becomes the 4 becomes DR and R3 becomes BDR. Got it? So I'll see one more command. Show IP OSPF neighbors. IP OSPF neighbor. See what is two-way?
It's a state.
Yeah, okay. DR other will go up to two-way. That is R1 and R2 will go up to two-way. This is a BDR and DR. It will go up to full state with the DR and BDR. With the DR other, it will go to two-way state only.
Okay.
Got it? Now I'll go to this R5 and R6 interface. In this, who will become DR and BDR?
R6 and
See, I
R5.
told you R6 and R5 there is a serial cable. If I go and see, so IP OSPF interface S0/0, it will show it as not broadcast. This is a point-to-point network.
Hmm.
Okay, if it is serial cable, you want to think that as a point-to-point network always. In point-to-point network, there is no DR and BDR election.
Okay.
Okay, between R4 and R5 elections happen
Yeah.
because this is a broadcast network. R4 I will go, R5 I will go. I can see here show IP OSPF interface F0/1. See here DR and BDR election will happen. See designated router is 5.5.5, BDR is 4.4.4. Even though there is only two routers, this election will happen when it is a broadcast network. But this is also like picking like point to point. But this is not point to point. This is a broadcast network. This is a point to point network. Okay. Here election will happen. Here election will not happen. Okay. Next, I will go to R2. I will see show IP route. See, all the loopback addresses are given as /32 only. /32, /32, /32, /32, /24. All the loopback addresses will be shared as loopback only. Okay. Before that, it will be shared as different. We have seen when you summarize it become 22 and sometimes 24 and 11. You can see 1.0.0/8 also. Interrupt panna. But you will never see all the loopback addresses always advertised as a loopback network only. Okay. What is the administrative distance? 110. Okay. If this is show IP protocols, I can see what are the protocols I am running. I am running OSPF. What is my router ID? I will get. Overall my gateway, what is the distance when it is last updated, I'll get it. What is the default distance is 110. Got it. Now I will change this network as broadcast network into point to multipoint network. What is my network now? Network type. So IP OSPF interface F0/0. What is my network type? Broadcast. Correct. I can change this broadcast. Okay. How? I will go to interface F0/0. Okay. IP OSPF network type is point to multi-point. I can change. Okay, if I change, what will happen? So IP ASPF interface F0/0. It becomes point to multi-point. I can change my network type also. What is point to multi-point? You will study in CCNA. What is point to point network? What is point to point multi-point network? What is broadcast? What is NBMA? Everything. Now this is a basic. How to change the network type. Still, I can change the loopback address also. Interface loopback 0. Okay, IP OSPF. My loopback address are given as /32 right? All the loopback address how it is advertising. OSPF route. All my loopback address are advertised as /32 only. Correct, because I made it as a point to multiply and I got detached from my network. Now I'll take it out that one. Interface and okay, my neighborship is now came up. I can change my interface address also. Interface network type also. Interface network type is advertised as loopback only. All the loopback advertised as loopback only. Okay. So how can I change IP OSPF network type as I can change like broadcast, non-broadcast, point to point and point to point. Okay, I'll change it as broadcast. I have to change only point to point. If I change as a point to point, how will I want to get it as /32? No. How I want to get here show IP route OSPF. I am getting still as a /32 only. How I want to get it is if I am changing as a broadcast network. If my loopback is changed as a broadcast network, how I want to get it as /24. I have to get it as a normal, not as a loopback. I want to get it as a /24 only. If I make it as point to point, I'll get it same only. If I am making now, I cannot able to do it. I can able to do it in router. But if I am making as a broadcast, I have to get it as a /24 only. Still, I can change my loopback address network also. Okay. Show IP OSPF interface loopback 0 FAC. The network type is point to point. Okay. If I am seeing R3, how I can see show IP OSPF interface loopback 0. It is a network type by default is loopback. It will send its loop address as /32 only always. Still, I can change the loopback address also as a network type point to point. Okay, got it. Still, it has a 10 hello timer, dead timer. I can make my host as a network type only. Network only. Got it. And another thing is show IP OSPF database. What is database? OSPF. It contains all the database about my network. First, what is state router link state area 1? This is advertised by this is a level called as link state. Okay, LSA types. This is of LSA type 1, this is of LSA type 2, this is of LSA type 3. LSA type 1 is given by each router. LSA type 1 is given by see one first router, second router, third router, and fourth router. Type 2 is produced by DR. Who is my DR will be given the netlink states. Then LSA type 3 is summary states. It is given by ABR. Who is ABR and who is ASBR? The router which is going to connect two different areas is called ABR. The router which is going to connect two different protocols is called OSPF with another protocol is called ASBR. Two different areas is called ABR. Two different protocols is called ASBR. Okay. So who is giving this summary? ABR is giving this summary. ABR is giving this summary. Then I will introduce about new network called 66. 66.0.1. Okay, I'll introduce a new network, okay, to R6 that it is connected to R6 like that. So I'll create another loopback address in R6. Interface loopback 1, IP addresses, past 66.0.1, 2.0.0. Okay, how I am introducing now, I will go to router OSPF process I'll go to OSPF process. I can redistribute the extra. This is the external network. I can redistribute this through redistribute connected subnets. If I give like this, it will be redistributed with me through OSPF. I can see the 66 in my routing table in R1. So IP route OSPF. I can able to see now 66, which is written as E2 routes, which is called as external routes type 2. Type 2 only will in CCNP only. Okay. Now I'll go to R2. If I see my database, same database, I will get another link state called summary ASB and type 5 ASB, which is introduced by ASBR. In database, first one is router generator, second one is DR generator, third one is ABR generator 1, fourth one is ASBR, and fifth one is also ASBR. Got it? Still